Welcome back to lesson 1.6. We're on example number 3. We're doing some composition functions, but now we're going to have some restricted domains. So what are our two domain restrictors that we've been talking about? There were two of them. One of them is when we have a square root, and one of them is when we have a fraction. Remember, the bottom of the fractions for those rational functions can't be 0, because when they're 0, that's where we have asymptotes and our function's not defined. And then for square roots, underneath that square root sign, underneath the radical sign, it needs to be positive. We can't take the square root of a negative and get a real number. So we need it to be positive underneath the square root sign. All right, for A, it wants us to find f of g of x, and then they want us to find the domain. So f of g of x would be f of x squared minus 9. So I'm going to plug in x squared minus 9 underneath the fraction, and then don't forget your plus 1. So this would be 1 over x squared minus 8. Now, when we want to find the domain of this guy, remember the denominator can't be 0 for a fraction. So x squared minus 8 can't be 0. X squared then can't be, moving that 8 over makes it positive. And so x can't be plus or minus the square root of 8, which is the same thing if we simplify it as 2 square root 2. So my domain for this one is going to be all real numbers, all x's, such that x is not 2 or square root 2 of 2, but x is an element of all real numbers. All right, looking at B, they want us to find f of g of x again, so we're plugging g of x into f of x. So I want f of the square root of x minus 3. So where I see x in my function, I'm going to put the square root of x minus 3 squared and then minus 2. Well, what does the square do to that square root? Kind of cancels it out, and we end up with x minus 3 minus 2, and that would be x minus 5. So what's the domain of this one? Well, domain of x minus 5, I don't see a fraction, I don't see a radical sign, so I would say all real numbers. But I would be wrong. Why am I wrong? Because back here at g of x, this has a restricted domain. So what I am able to plug into f of x is restricted. And what is it restricted by? Well, x minus 3 has to be greater than or equal to 0. So x has to be greater than or equal to 3. So even for this piece of the function, for the f of g of x, that composition, it's restricted by the same thing as g of x. So the domain for this one is going to be, let's see, x greater than or equal to 3 would be 3 to infinity. All right, go ahead and pause your video, try the you try A and B, come back when you think you have it. Welcome back. Hopefully you've tried out A and B. How'd you do? So let's find f of x squared minus 1. That would be the square root of x squared minus 1 for my x, and then plus 1. That'd be the square root of x squared, which is going to be plus or minus x. Now, does that work for everything? Well, no, because, well, actually in this one it would. Do we have any restrictions on our g of x? Nope. And then when we plug that into this piece here, no matter what I get, this 1 and negative 1 is going to cancel out. I'm going to have something squared. Something squared is always going to be positive. So this actually is not going to be plus or minus, because if I take the square root of a positive number, it's always going to be positive. So we actually don't even need the plus or minus. And since it's always positive, the domain for this one is going to be real numbers. Now, I can't say that's always true, but for this particular problem it is. And then finally for B, f of g of x would be f of x squared plus x. So that would give me 5 over x squared plus x. Well, even though the g is not restricted, the f is, because x squared minus x can't be 0. When I factor out an x, I get x times x plus 1 can't be 0, which means x can't be 0, x plus 1 can't be 0, and so x can't be -1. So my domain for this one is going to be from -infinity to -1, union -1 to 0, union 0 to infinity. And that's it for lesson 1.6. Head on over to your homework.